Today I've got myself a kind of a basic little light, kind of a camera or video camera lighting rig. This is mainly just for kind of experimenting with and seeing what's an option. I found issues with kind of recording at home when it's quite bright daylight outside. I need some kind of additional lighting option, and so this was relatively cheap, a nice thing to play around with. Came with various different kind of coloured filters in here to kind of fake the colour temperature that comes out. It's a very bright light. I think it's probably going to saturate this at an extreme level. And this is run from a series of A batteries on the back, totaling, got up to 9 volts in there. And you can also fit into here a kind of camcorder batteries. It doesn't fit anything I've got. An AA battery is going to run through this quite quickly. It's got a little test battery light in there. You've got a switch on the side is for the turning it on and brightness control, and that is about it. You've got a little kind of camera tripod mount here, kind of a hot shoe mount for putting on top of a camera. It's a little bit weighty, but it also fits into the base of a tripod. So I'm going to take this apart now and take a look inside and see if there's going to be easy modifications, hopefully to add some kind of external power option, either some kind of possibly 12 volt DC jack, or maybe the ability to plug in a kind of a lithium ion battery pack, like these larger packs here for kind of robotic vehicles, remote control kind of vehicles or planes. That kind of thing could work quite well with this, providing power. And so I'm going to take a look at that as well. I don't think there's going to be any other changes to it other than possibly the power source. It might be nice to see how feasible it would be to look at the current draw possibly, and see if I could add some kind of step-up 5-volt converter so it could run from a USB power source. But that's only going to work if this is drawing ideally kind of half an amp. That way it could run from a 1 amp 5-volt DC source. So I'm going to dismantle this case now, take out these existing batteries, which are quite warm actually. I've been running this for a little earlier, and clearly they've warmed up a little bit in that time, which implies the current draw might be quite heavy, and it is pretty bright in here. Looks like there's just 4 screws around the side to dismantle that. Should be. Yeah, so it seems to come apart quite nicely, this particular item, which is always a good sign. So it does seem to be roughly the same shape and style as another more expensive unit I was looking at, which had kind of colour intensity control, so you could alter the colour temperature. And to achieve that, they must be using kind of RGB LEDs into control circuitry. And so that's very kind of similar shape and style. So it's possible this, it's unlikely this is just a lower model of that kind of thing, but presumably they've kind of copied the rough style in some form. So this front panel just seems to pull straight out. That doesn't seem to free up anything else. This back piece is fully moulded by the looks of it. So it looks like the front LED panel will have to be unscrewed, 4 additional screws in the corner. I'm guessing these LEDs inside are going to be wired into little chunks to run from the another 5-volt supply, or possibly the electronics might be a bit more fancy to accommodate the variable intensity options, but we'll see what's in there. Looking through the side vent, you can see a few through-hole components, so I'm guessing it's going to be quite basic inside. Okay, so it screws out, and it seems to be got the board here. It's wired into grids in there, And yet that's still within the moulded plastic somehow, so there's got to be another option to kind of separate these parts out at some point. Can't see any other additional screw holes in there. Doesn't appear to be anything from the front. So this isn't moulded here. So is that going to pull away? There we go. So that piece drops out. So it's wired through these holes here, so I'll have to stay like that for now. And inside the unit, we've got two little circuit boards hooked up by massive wires here. So this front board here, possibly for battery control. We've got kind of the switch here and the LED intensity. Oh, for the battery level in there. Not sure if you can see what part number is. I'll have to take a look at that in a bit more detail. On the side here is the intensity control, this main power switch. There's no obvious signs of what's controlling that. There's a silk screen outline for a little kind of IC in there, but there's nothing there. There's no pinholes, so it's possible there's a component mounted on the reverse. Try to unscrew some of these circuit boards now and see what's inside. So it's those parts out. You've got various different kind of jumper connections here, so this is for the different types of batteries. It supports, as well as the regular AA set. And these all appear to be coupled up just in parallel, so you've got the three different types of battery connections: the small kind of camcorder battery, the large camcorder battery, and the AA terminals down here. These then feed down to the secondary board, and presumably you've got red for positive. This board here, I'd expect, is just going to be purely for battery measurements, and they do have a microchip in there, which is a little unusual for that purpose, along with all those resistors. So I'll take a look at that part in a minute. And that is, and there is also a micro switch in there, which I didn't notice anything for on the front. So that plugs in like so. Oh, that's the test button. So the test button is on the secondary board here. So that is probably going to be a direct connection between here. So these two lines here, one from the battery and one to this board, they're going to come in at these points here and here, so they're kind of coupled together. And the positive feed here is connected via the switch. So this is a standalone power management or kind of battery level meter that is connected to the batteries directly when this switch is pressed. And to the rest of this board here, we've got two more ICs on the underside, various different components on the top. That should be some kind of battery kind of switching circuit, PWM control, I'd imagine, and a bit of filtering on here, larger power resistors, and a fuse by the looks of it, which is a little surprising to see on a battery powered component like this. So I'm going to take a look at the part numbers now on some of these bits and see what's going on. The chip on here, well, there are three kind of chips on this circuit board. Got that one there, and these two here. They've all got marks on the die, and this is covering the part number. You can see quite clearly in this one, it's kind of very specifically covered over the model number, the LM model number, a part number, and it's either part of some kind of testing process. Someone's kind of checked off that works, or they've intentionally tried to block it out. But should be possible to scrape this off without too much difficulty. Now it looks like the markings, what I thought were markings, actually they've done some damage to kind of scrape off or engrave something on the chip. You can just about make out that it's not quite uniform there on that one. It looks like they've a bit of the edge has been kind of scraped off, and this has been quite carefully to each of the parts, so it's quite bizarre. So it's possible they don't want people to find out what kind of parts they've used, maybe trying to make the idea of copying these components a little bit harder. So rather than just buying another kind of manufacturer, kind of cheap manufacturer, buying one of these and duplicating it like for like, they've actually got to do their own little bit of research and kind of electronic engineering to work out how these have been done. But it does make kind of investigating, working out what's going on here quite a lot harder, which is really irritating. So the circuit, well, I can't say for sure how it works. It appears we've got the power kind of coming into this terminal here. This then runs down to here, and this is the switch. This is part of the kind of variable resistor in there. At one end, you've got that click where it switches on and off. And so the power kind of comes into here, across the switch, and across here, which is the fuse. And so that kind of jumps across to here. There's a couple of capacitors and resistors just to protect it, and then into this IC at the end. There's be some kind of power driver or kind of MOSFET transistor circuit, something like that. And so this is the output line of the chip here. That then connects to an inductor down to here to kind of smooth out some of the high frequency, and a couple of capacitors across the output. Then over to the final output to the LED light here, and then that returns through here. Got a pair of kind of high power resistors in line, and then that connects across to the negative line here. And we also have a bit of power being fed off into here. So this will be some kind of driver circuit for this chip here, variable kind of oscillator connected to the variable resistor in here. So you can't say for sure without these parts in here, or someone, at least I can't, but that appears to be how it's kind of functioning. The obviously this circuit here, it's the kind of part, you can see the first two numbers, it's an LM, so it's whilst it's not one of the most kind of common bar graph type display chips, I expect it's going to be that kind of thing, although it is using quite a lot of components on here to kind of do its job. Yeah, it's got quite a high component count for this type of device. And alright, so this is the positive feed coming in here down into the chip. Then the negative line's got this TO92 package here. Got two terminals are doubled up, so that could just be a dual kind of diode package, something like that, just to protect it. A capacitor coupled across that, which is a little odd. And yeah, and then the rest of that. And it looks like this will run from 9 volts quite easily. I'm just going to tap into this line now and measure the current consumption of this. So I've cut the power line, and I've got an ammeter set up here. See what's going on. And so if I've turned it up to full brightness now, if I connect this across the power line, so it powers up with 250, 260 milliamps, but the brightness of this light doesn't seem quite right. So I switched over to the 10 amp scale, just out of curiosity. The inside, when measuring the kind of with the 10 amp line, there's a big kind of solid, kind of very low resistance loop between these two terminals, unlike the other one where it's much higher resistance going on. And so I thought perhaps that was affecting something. And if I switch over here, it is significantly brighter, and it's pulling about 1.5 amps. So clearly the small amount of resistance in line when we were looking at that was impacting things a lot. If I just about tweak this, so full brightness 1.3 amps at the moment, though the batteries have been running, so that could be dropping it, and the slight changes really start to drop that current down. It's 300 milliamps, 200, 100, and it's kind of at its lowest setting. It appears to be about 30 milliamps, something really small. It's worth switching back to the other scale for that one. Yeah, so seeing the correct value there, 30 milliamp draw, and that one. Switch back to auto ranging, and that, and up that a little bit. And so yeah, it's pulling out quite a lot of power. So if I wanted to run this, I think 5 volt power supply stepping up is definitely out the question. And it's most likely going to be a 12 volt power supply I can bring up to feed this. Something that will drop down. It doesn't appear to have much in the way of voltage regulation. I mean, it might accept a bit of a wider variety. I'm going to take a look at the current kind of capacity, or the voltage of some of the kind of camcorder batteries this thing supports, and see what their range is. I might be able to run it straight from 12 volts successfully, but if not, there should be plenty of room in the case to drop in a small kind of a 9 volts linear regulator. A couple of amps on that should do the job, and it's only dropping between 12 volts and 9 volts, so it's not going to be dissipating a huge amount of power, so hopefully it shouldn't require any kind of cooling on that. And so it's a fairly basic little light. This is one just picked up from Amazon. It's got the model number CN160. There's 160 LED bulbs in this thing, but they are pretty good. They are effective. They do their job for this kind of thing, and with a small modification, it should be possible to get this running from an external power source. It would be quite useful. It's just a shame about the fact that they've scratched off the part numbers from those components. I've got myself an 8.5 volt voltage regulator. It's slightly odd voltage, but the ratings for the light were a little bizarre. Hidden in the documentation was a voltage range, and I think it approached about 8.4 volts as the upper, so not quite 9 volts, which is supplied from the battery. But I did notice that when you're running at full load, obviously it is only running from AA batteries, and they do have some reasonable internal resistance, and so when you're trying to pull an 1.5 amps, the voltage across the light drops significantly. It's down a volt or two, and so it's well below the kind of 8.5 volts kind of maximum, or 8.4 volts maximum. So I've got this 8.5 volt voltage regulator, which should do the job. I'm just going to hopefully kind of modify that now. It will have a couple of probably about 5 or 6 watts I think to dissipate at full load, which is potentially going to be an issue. So I've got a handful of kind of heatsink parts around. If the worst comes to the worst, I have this to mount on the back. I'm hoping it won't come to that, so I'm going to kind of rig it up outside the box first, and kind of take a look at the temperature under load and see what it gets to, and hopefully one of these will suffice. So I've got the light here just running off a bench power supply for now. I do want to leave this to run off battery power as an option, and so what I'm going to do is repurpose some of the other connections inside. It's got 3 kind of battery terminals in here it kind of jumps through. Some for the AA batteries, and it's also got these other terminal sets in here, which are designed for the kind of camera batteries it can plug into. So I'm going to desolder one of those and use that as the kind of power in. I do have to be careful though, because I can't be powering it externally and have have batteries plugged in, because otherwise I'd be feeding power into the AA batteries, which isn't a good thing. It might be worthwhile putting a diode in there to kind of protect that feed, but that will then have an even more significant effect when running off batteries, because the voltage already drops some. I'm going to lose another kind of half a volt or so across that. So I'm going to disconnect some of these terminals here, and I think use that as the input feed. So I've got a very, very crude setup in here, just quickly soldered onto the wires. I'm going to just test that to make sure it works as expected. On a little bit. It still functions as being powered by the voltage regulator now. One thing to be very careful is when you go to feel these, they can get very hot, certainly without heat sinks. I did make a mistake a few years ago and went and gripped one of these quite tightly and ended up with the kind of imprint of a TO22 on my finger for a couple of weeks. So I'm just going to get a multimeter now so I can kind of measure the voltage and take a look at the temperature properly. This is a relatively low dropout regulator, I believe, but so at the moment we're feeding 7 volts in, and on the output it's showing about 5.6 volts. It's got a voltage drop of around about 1.4 volts, which is not a big deal, because we're going to be feeding into this thing 12 volts, and we're hoping to get 8.5 out. So that gives us a 3.5 volt leeway anyway, so it's not something we need to worry about for this. So increase this to 12 volts. You can see, confirm the output voltage here should be 8.5, but we're approaching close to 9 volts here. It's a little bit more than we're after, but it shouldn't be too bad. I'm going to increase the brightness here. Obviously this is going to now increase the current and the power draw. Yeah, I've just quickly pulled that up, and I'm seeing 1.4 amps being drawn. That's kind of what I was expecting, and that's what it was kind of pulling before, so we're not seeing any significant problems. So just try and measure the temperature here. So I'm not going to get a particularly good thermal contact between but just from that brief bit here into it's approaching 50 degrees at least. If we power this back on, bring it up to an amp current draw. So that's drawing 1 amp now. You can see the temperature is climbing pretty rapidly, and these things will kind of go up to about 120 degrees before they cut out. That's not something we want to do. So I need to try a heatsink of some kind now. I'll try one of the ones I've got on the smaller ones and see how that fares. To make the testing of this a little easier, I've just bolted the heatsink on the back and just at an angle. It's making good enough contact with the die, so it's not a problem for this testing. I don't have any thermal compounds or any kind of bonding layer between the two, which isn't great, so the performance could be better, or would be better if I did get around to, or did put something in between, but hopefully it should give us an idea of how this is going to function. So I'm going to bring this back up to 12 volts feeding in and 1 amp current draw. and see how this fares. Now pulling an amp, and we've got so unfortunately I don't think I'm making as good a contact this time round, but it's not horrendous. I'm still kind of touching the metal plate. The temperature's climbing, but it's pretty minor. I'm holding the heatsink here and it's definitely feeling warm, and we're seeing 40 odd degrees here, 45, 44. I'm going to increase this up to the full brightness now. I'm kind of drawing about 1.5, 1.4 amps. See how it affects it then. It's now drawing 1.4 amps, it's at full brightness. And the temperature's starting to rise again. So I am holding this heatsink here, so I will feel it when it gets too hot. But I think I'd be happy with 50 odd degrees, as long as you know not to touch this thing on the back. Be a bit more, because it's still well under the kind of maximum temperature for this thing. So I'm measuring the temperature here in the screw head, just in the back. This is a fairly good point, because this does bolt through the actual die itself, or the heatsink attached to the die, so it makes fairly good contact with that. So it is getting quite warm to be holding onto here, and it is still slowly climbing up. The current draw is also dropping very slightly. It's dropped by about 20 to 30 milliamps. It could be it's quite possible, if you looked at the data sheet for this regulator, you'd see some slight variations as the temperature kind of worked its way up. I'd expect the actual die temperature of the regulator to be a lot higher at this stage. Okay, there we go, there's on the front, kind of butted up against the die, and we're jumped straight up to 65. So I'm going to let that sit for a few minutes and see how the temperature varies. So this is now going up to about 75 degrees, which is, I think, a bit warmer than I'd like. It's still climbing very slightly. The larger heatsink I had is, whilst I don't think it would look too horrendous bolted to the back of this thing, I'd like to try and avoid using it if I can. So what I have is this board here. This is the high voltage board from the laser printer I tore down a week or two back, and on here we've got two nice TO22 package heatsinks, and I think it's they're better quality than the kind of flimsy little bit of kind of bent steel that's currently attached to this, and so I'm going to pull out one of these, bolt it on, and see if I can get better performance. Okay, I now have the slightly larger heatsink attached. I'll take a look at the temperature on that one. I expect it to be a little bit lower, whilst this heatsink is a little bit denser. It does have a lot more kind of fins to radiate heat. I'm just going to let that sit for a few minutes and see what the temperature reaches. So this heatsink is a fair bit over 60 degrees now, and so I'm going to give this one a go. I think in an odd way this might mount particularly nicely on the back of this unit, so I'm going to plug this in or wire this up and see how it performs. So, despite looking a little ridiculous, this thing is connected up. Again, I'm now going to let that sit for a few minutes and see what the temperature reaches. So I left this running for about 10-15 minutes, and it reached a peak temperature around about 35 degrees. I think it is pretty minimal, so I'm very pleased with this option here. I'm still slightly sceptical about it, but I'm going to dismantle this setup now. I'm going to bolt the heatsink to the bolt the voltage regulated heatsink properly, and then kind of have a look at how that could fit to the back. I'll heat shrink up the wires and have them kind of run around and into the body of this unit. So I've mounted the voltage regulator to the heatsink. I've put a bit of heat shrink around the leads, and that will then kind of run off on the back of the device. Obviously I still need to get power into this thing, and so what I've got here is just a little barrel jack socket, and I found looked through the box and I found a power supply here, which is 12 volts at 3 amps, so it'll be ideal for this. So what I'm going to do is mount this in the side here. I've drilled a little hole in the side, and that will allow me to kind of mount the connector in like so. You can then plug in from the side. To attach that, because the connector I've got is a PCB mount one, I'm going to glue this in place with hot glue. It's a nice simple way of holding this in place while it glues, is to plug the connector in, and I can then hold this against the edge whilst the glue sets. That way I know it's perfectly kind of positioned. Once it's set, I can then solder onto the connectors as they come out the top and finish wiring this up. I've finished wiring this up now. I've got a little barrel jack connector mounted in the side, and that's feeding out to the kind of main ground line, and also power lines out to the voltage regulator, and then this is the return voltage regulator tapped into the main positive feed. And I think when this front cover goes back on, that should kind of cover away quite nicely. The heatsink on the back is there. I think I'm just going to glue this on, to be honest. It's I think this modification's already slightly silly, and so I may as well make that change. If I really wanted to, I could crack that off, remove it, and revert back to battery power, so I haven't kind of broken anything or changed it permanently in that regard. I'm just going to do that in a moment, and if I power this up with the 12 volt feed, it all seems to work successfully. I'm going to just finish off, screw this back, glue the heatsink on the back, and I should be done with that. So here it is, complete. A slightly ridiculous modification, but it is functional. So it does make it a little bit more useful considering the amount of power it used and the rate it would go through those batteries. So it's always going to be fully charged now. I certainly wouldn't recommend that kind of modification. It is a bit of a joke more than anything. If I was to do it again, or if I'd given it a bit more thought, I'd have found a nice kind of little switching regulator, which would have fitted perfectly within the battery compartment, meaning there's absolutely no need for that at all. But it's done now, and assuming there are no mounting weight problems when I put it on a tripod, I will leave it as is. Obviously, if it turns out that it is too heavy, kind of top heavy with that on there, then I may kind of pull that off and kind of do it the alternate way. So you have it, a basic camera light, now powered from a generic DC, or 12 volt DC power source.